They say imitation is the sincerest form of flattery. Well, today, I'm going to show you how I took inspiration from another maker and turned it into something uniquely mine through a journey that involved a lot more trial and error than I initially expected. Bob from I Like to Make Stuff created this amazing vertical camera slider that immediately caught my attention. What really struck me was how perfect this concept would be for my setup, with a few modifications, of course. And over time, he actually ended up making 2 different videos about this, and he iterated and improved the design between the 2. Little did I know at the time, I'd end up following a similar path, making one version, learning from my mistakes, and then completely revamping it into something, in my opinion, that's even better. I designed the entire camera rig in CAD before touching any materials or firing up the 3D printer. During the design process, I even went live while working on the base design. You can find a link to that stream in the description below. The final design called for a substantial base measuring 23 inches across, which resembles an office chair base with casters and a central mounting point. Due to its size, I had to get pretty creative with the printing strategy since it was much larger than my 3D printer's print volume. I printed this in multiple sections, starting with the center hub, which is like a hollow cube designed with mounting points for each of the legs. This hub would serve as the central connection for the entire base structure. I printed one leg at first as a test piece. Each leg needed to be mounted securely to the center hub while providing stable support for the casters. And here's a fun fact for you. Most of the hardware for this project was actually a Christmas gift from my in-laws, Bill and Kathy. They had no idea what these random parts were for, but they trusted me. This video is actually the first time they're seeing what this gift turned into. For the vertical support, I used a 20 by 60 millimeter aluminum extrusion. The mounting system used 2 steel brackets sandwiched together with a custom 3D printed spacer for proper alignment. Each bracket has 4 mounting holes, but since they overlap, they share the 2 center holes, resulting in 6 bolts total connecting the bar to the base. For connecting these brackets to the aluminum extrusion, I initially tried 3D printing some V-slot inserts. Those mushroom-ish shaped pieces that slide into the channel and kind of tighten down. I had high hopes for this approach since it's a pretty common solution, though looking back, I probably should have known better. As it turns out, this would come back to haunt me a little bit later in the build process. The roller assemblies were next. These are what allow the camera mount to slide up and down. I chose this 60 millimeter extrusion after learning from Bob's videos. With a narrow piece, the rollers would interfere with each other as they passed by. This simple change made a huge difference in the smoothness of the operation. The top roller assembly was the first component I designed. This required precision measurements to fit both the aluminum extrusion and the steel cable pulley wheels. 2 3D printed halves sandwiched the pulley wheels with one end shaped to slide snugly over the extrusion, including the V-slot. For the counterweight system, I designed a simple but effective solution. A 3D printed box roughly 3 inch by 5 inch mounted directly to one of the roller assemblies. Inside, I added various steel chunks and bearings and weights and other things I found laying around my office to add weight to the one side. The initial camera mounting system showcased one of my better ideas. Rather than permanently attaching the camera, I created a custom holder for my small rig tripod. This allows me to quickly remove the entire tripod setup when needed for handheld shots. This design element works so well it actually survived into version 2 of this assembly that I'll get to in just a few minutes. So after a few weeks of use, 3 major issues became apparent. First, the mounting system I designed using 3D printed V-slot inserts just wasn't strong enough. The whole thing wobbled back and forth as soon as I touched it. It looked great in CAD, but in reality it just didn't work out. Then came problem number 2. It was too tall. Couldn't even fit it in my closet. Sometimes you don't realize these things until you've built the whole thing. The third issue became clear after using it for actual filming. Lighting was a constant challenge. With just the camera mount, I found myself constantly struggling to get enough light into the right places. I had this LED panel gathering dust that could solve this problem, but no way to mount it to the rig at the moment. And these issues weren't just like minor inconveniences, they were making the whole rig practically unusable for my workflow. I had 2 choices, either scrap the whole thing and start fresh, or figure out how to evolve the design into something that would actually work. Being both stubborn and thrifty, I chose the latter. The solution to the wobble was actually really simple, once I stopped overthinking it. I headed out to the barn, fired up the drill press, and created a rock-solid connection by drilling straight through the aluminum extrusion. 4 bolts running all the way through with nuts on the other side. No more wobble. For the height issue, I simply cut down the aluminum extrusion with a regular wood chop saw. But here's where things get interesting. Instead of viewing the leftover pieces as scrap, I saw it as an opportunity. That spare piece of extrusion became the catalyst for solving our lighting problem, and it taught me an important lesson. Sometimes our best innovations come not from following the original plan, but from being flexible enough to recognize and adapt to unexpected opportunities. So I took this extra piece of extrusion and I designed a center bracket that connects the vertical slider with a clever feature. A hollow rectangle that allows the horizontal aluminum extrusion to slide through it. Learning from my earlier mistakes with the V-slot inserts, I created a new mounting system with 4 strategically placed screws, 2 on the top and 2 on the bottom, that lock everything in place. From there, I designed 2 mounting pieces. The first holds the small rig tripod and includes a spot for a USB battery pack. The second mount, about 6 inches out on the other side, incorporates an old tripod head that I'd laying around. This gives me a fully adjustable mount for the LED panel using standard Q20 camera mounting hardware. The beauty of the system is how everything slides and locks into place. The horizontal bar uses V-slot inserts, which work perfectly fine here since they're not under the same amount of stress as the base mount. I can position both the camera and light exactly where I need them, and everything stays rock solid. So what started as a simple imitation evolved into something completely custom and way more capable than I originally planned. The final design is incredibly versatile. I can adjust the height from floor level to eye level in seconds, quickly remove the camera when needed, and even have perfect lighting for every shot. So let's take a few minutes and break down everything that went into this build, and I mean everything. So starting from the ground up, we've got 4 basic casters from Home Depot. Nothing fancy, just solid and reliable. The 3D printed base structure, which required 2 spools of ABS glass fiber filament for the 1 central hub piece and the 4 legs that attach to the hub. The mounting hardware included 2 steel mounting brackets for the vertical support and 26 stainless steel nuts and bolts for the entire base assembly. Next was the 20x60 millimeter V-slot aluminum extrusion, which was just 1 piece, but I cut it into 2 for iteration number 2 of this camera rig. Next is the sliding components, which is the 2 roller assemblies for the smooth vertical movement and the 2 pulley wheels at the top for the cable system. Speaking of the cable system, I bought a steel cable kit with rubber coating and mounting hardware, and that was just purchased at Lowe's. Next are the additional 3D printed parts throughout the entire system, and this took about a spool of PETG filament. This includes the 3D printed assembly for the top cap where the pulleys ride, the counterweight box, and the 3 mounting pieces that hold the horizontal bar and the cameras onto the actual rig. Finally, we have the business end of the whole thing that includes the small rig tripod, quick release camera mount, the LED light, and the repurposed tripod head that I used for connecting the light to the mount. Also, there are various M4 and M5 screws for the final assembly. When you lay it all out like this, it might seem like a lot of parts, and it is, but each component serves a specific purpose, working together to create something that's exactly what I needed for my setup. So while this project started as an imitation of Bob's design, it evolved into something uniquely suited to my needs. All the CAD files and parts list will be available in the description below. Let me know in the comments what you think of this build, and if you'd like to see more details about any specific part of this process. Thanks for watching, and I'll see you in the next video.